Hey guys, what's up? It's Eric with Advanced Level Automotive. Welcome back to the channel. Welcome back to another scorching hot day here in Houston, Texas. Today, I'm here at the shop taking a look at this 2013. It's a Ford Edge. It's got the 4-cylinder 2.0 liter Ecoboost engine. Now the shop is telling me that they recently replaced the transmission in this thing, and after replacing the transmission, the truck was running and driving. However, whenever they came to park the truck, after that the truck wouldn't start. It doesn't crank. They're also telling me that they connected the scan tool and there is no communication with the PCM. So they asked me to take a look at it. You guys already know how we do it. Let's get started. All right, so first of all, let me show you guys that I've got my jump box connected because the battery is completely dead. And what they're telling me is that this truck has actually been sitting for a couple years now. And you can see the date code on this battery is 2018. So anyway, they have been doing some work on it. So you can see that they've got the lid removed on the fuse box. So they have been doing some poking around. They did check to make sure that the grounds were all attached. However, the truck still doesn't crank and we have no communication. Oh, and the other thing that they said was they did make sure that the connectors were connected here on the PCM, and then over here I believe this is the TCM, and so the connectors here are fully attached. However, we don't have any communication. Now let me take you guys inside where we've got the scan tool connected. All right, so we're inside the truck. Let me show you that I've got the keys right here in my hand. Now I'm going to attempt to put my foot on the brake, and I'm going to see if we can crank this thing. And you guys can see that I'm pushing the button here and nothing's actually happening. Let me check my jump pack because it's not even powering up right now. Okay, so my jump pack connections are good. Let me double check to see if my jump pack is on. Yep, it's on. Let's go back inside. Well, let's try this again. Let's see if the ignition powers up. And nothing's happening. Okay, that's interesting because when I first got here, the instrument panel was coming on and so was the radio. What's the deal here? All right, guys, so I think I know what's going on here. So I had the jaws for my jump pack on the negative side here clamped to this little piece of the terminal here. But if you guys look, you can see it's pretty rusted and oxidated. So when I moved it from here to this side over here, I don't know if you guys heard that, we had some nice little sparks going on there. So let's move back inside. All right, so moving back inside the truck, you can already see that the instrument panel is powering up here. And so let's see if we can get this thing to crank. I'm gonna put my foot on the brake and push the button. This powers up, but the vehicle does not crank. The engine does not start. Let me go ahead and power up the ignition. Okay, so after powering up the ignition, the first thing that I noticed here is that we actually have a lot of messages on the instrument panel here. So if you look, we have service advanced track, we have this low engine oil pressure, engine coolant over temperature, and let's see what else we got. Low tire pressure, of course. The radio just came on, so let me turn this off over here. How do you turn this thing down? Oh, there we go. Okay, so moving back over to the instrument cluster, let me show you guys something that's really interesting here. So if you take a look at the mileage here, you can see that we have just a bunch of dashes. That's a good indication that we don't have communication with our PCM. And if you guys wait until we get the message for the DTE right there, so take a look at that, you can see that we have dashes where it says mileage to empty. And so that's also a good indication that we're losing communication with the PCM. If you guys are ever working on a Ford vehicle and you guys see those dashes where the mileage is supposed to be, suspect the communication problem. Okay, so over here I've got the scan tool connected, and today once again we're going to be using the X431 Pro 3S Plus from launch. I'm going to click on Intelligent Diagnose. We're going to let this thing read the VIN number, and as you guys can see, as I suspected here, it's not able to read the VIN. It wants us to manually input it. I'm going to skip that for now, because what I'm going to do is I'm just going to go back over here to Local Diagnose, and we are going to select the vehicle. So let's go to American, click on Ford, then we're going to click on Manually Select. Let's see if we can locate Edge. Right over here, we're going to click on Edge. Once again, this is a 2.0 liter, so we're going to click on 2.0. And this is the Ecoboost, so we're going to click on Ecoboost. And this is a 2013, so we're going to click on 2013. So I'm going to go ahead and run a health report, and what that's going to do is it's going to scan all of the modules on the vehicle, and we're going to see what we do and what we don't have communication with. So you guys can see that we already have communication with the ABS, ACM, APIM. We also have communication with the BCM. We'll let this thing finish scanning. Okay, so this thing is done scanning. Starting up at the top, you can see we have the ABS module, and in here we have a few codes for battery voltage, brake pedal switch A. And then we also have this U100. It says missing communication with ECM or engine control module, also known as the PCM powertrain control module. That's a pretty important code. It gives us some direction here that we don't have communication with the PCM. And so looking over here, you can see the ACM, we have a battery voltage code. APIM, we have battery voltage code. Of course, the battery, like I said, in this thing was getting low, and so that's why I had to put a jump pack on here. So I'm not surprised that we have a bunch of battery voltage codes here. Looking at the BCM, you can see that we have a U100, again, missing communication with the ECM, also known as the PCM. Then if we scroll down here, you can see that we have some more battery voltage codes. I'm not worried about those. Looking over here at the front lighting control module, you can see it says it's got communication problem with the BCM. And then over here with the GPS, you can see that it's got invalid data received from the BCM. So we may even have a problem with the BCM here. Check out our HVAC module. Again, you can see that we have some codes for communication problems with the ECM or the PCM. Then if we scroll down here to the instrument panel, once again, we have some U codes for ECM, PCM. Also, we have a code for the BCM, invalid data. So that may be an important one as well. Then if we scroll down here to the occupant classification system module, you can see that we're missing communication with the ECM, PCM. So a bunch of communication codes here. And like I said, we're showing communication with every other module on this vehicle. However, we don't have any communication with the PCM. All of these other modules, the steering control module, the BCM, the RCM, the instrument panel, all of these modules have communication. The only one that we're not showing here is our PCM. Typically, when you have communication with every other module on the vehicle, however, you're only missing communication with one module, we can generally rule out a problem in the CAN bus communication system. Not always, but for the most part, what I'd like to do is shift my focus over to checking our main powers and grounds for our PCM and trying to figure out if we're missing any of them. Then if we find that we have everything we need as far as powers and grounds, we'll move over to checking out the CAN bus communication system. So let's move over to the wiring diagram and get some more information on this. All right, guys, so before we start dissecting the wiring diagram, I do want to take a moment to give you an idea of my thought process. Now, some of you guys who have been following the channel long enough, you'll know that whenever I deal with a no communication problem, in this case, we have a PCM that's not communicating, there's certain things that I like to look for. So number one, I want to look for powers and grounds. I want to make sure that all of the main powers and grounds are being supplied to the PCM, because without them, this PCM is not going to be able to function. The second thing I like to look for is a 5-volt reference. If we have a problem where the 5-volt reference is being shorted to ground, then that can also cause a no communication problem. Now, the third and final thing I like to look for is a problem with the CAN bus communication system. We need to make sure that we have good continuity between the PCM and the rest of the CAN bus communication system. So with that in mind, let's go ahead and start by taking a look at the diagram that shows all of our powers and grounds. Okay, so here we have the diagram that shows all of our main powers and grounds. Now, the cool thing about this is that Ford was actually kind enough to put all of our main powers and grounds on one page, and so that's going to make it a lot easier for us. Now, if you guys take a look at this rectangular box here in the middle, this is going to be our PCM, or our powertrain control module. Then if you look at the rectangular box up here at the top, this is going to be our battery junction box, also known as the fuse box that's under the hood. Then if you look over here on the right hand side of the screen, this box is going to be our body control module, also known as the BCM. So taking a look inside of the PCM, you can see that down here on pins number 1, 2, and 4, these are going to be our 3 main grounds. One thing to note is that if you take a look at our 3 ground wires, you'll notice that they actually all meet up at the same ground point. Now, if we take a look at pins number 5 and pins number 6, you can see that they're designated as V power. And if we follow these powers, they come through on these white and violet wires. And if we follow these wires up, you can see that they actually join together at the fuse box, and they get their power from this 20 amp fuse, which is fuse number 69. Now, if we follow this power through fuse number 69, you can see that that power actually comes from the PCM power relay. Now, this PCM power relay pretty much works like any other 4-pin relay. On this side, we have our load or switching side. Then on this side over here, we have our control side. Now, starting with the control side of the relay, you can see that on pin number 2, if we follow it out, it gets its power from fuse number F86, which is a 7.5 amp fuse. And that power that comes in on pin number 2 is going to go through the coil winding of the control side of the relay. It's going to come out on pin number 1. And if we follow it out, you can see that on this brown and white wire, it goes back to the PCM at pin number 27. Once the PCM grounds pin number 27, that's going to initiate current flow through the coil winding of the control side of the relay here. And once that coil winding energizes, it'll magnetize. And once it magnetizes, that's going to close the switch here on the load side, which in turn is going to allow the power from pin number 3 to come out on pin number 5 and eventually reach our F69 fuse. Now, if we move over here to pin number 15 at the PCM, you'll notice that this one is labeled ISPR. Now, I'm not going to lie, I didn't exactly know what this stood for. I did have to do a little research. And what I found was this stands for Ignition Switch Position Run. Basically, this is referring to the power on pin number 15 as an ignition power, meaning that this power is only going to be there with the ignition switch on. Now, if we follow pin number 15 out through this yellow and orange wire, you can see that it comes from the fuse box and it gets its power from fuse number F90, which is a 10 amp fuse. And if you look up here at the top, you can see that this fuse is only hot in start or run. Now, moving over to the final power that we need to check is going to be pin number 14. And if you look here, it's labeled PCM wake. Now, this one's pretty interesting because this is the first time I've run across this PCM wake signal. But basically, if we follow this pin number 14 out on this violet and orange wire, you can see that it goes to the BCM. What happens here is that the BCM has a fuse inside, fuse number F18. It's a 10 amp fuse, and that fuse is hot at all times. And so there's a power being supplied internal to the BCM. And if you look in here, you can see there's a transistor. Now, if you guys understand the basics of a transistor, essentially what this is, it's a gateway or doorway that allows the power to flow. And so essentially what we have is the power coming in from this fuse is going to the collector side of the transistor. And whenever the microprocessor sends a signal to the base circuit of the transistor, that's going to open up the gate or open up the doorway and allow the power to flow through the transistor and out through this violet and orange wire and finally reach the destination here at pin number 14. Now, the interesting thing here is that I'm not exactly sure what conditions need to be met in order for the BCM to wake up the PCM. I'm assuming it has something to do with the ignition switch, or it could even be something as simple as opening up the door. There's some type of signal that the BCM is looking for before it's going to send out the power to the PCM to wake it up. So it's really important that if we need to come here to pin 14 and check our PCM wake signal, we need to make sure we do it with the ignition switch on. All right, so moving on to checking our 5-volt reference signals. And what I basically did was I went through the powertrain control module wiring diagram, and I basically looked for all of the pins that were designated reference signals. And so starting up here at the top, you can see that pin number 15 is designated as a VREF signal. And if we follow it out here, you can see that this reference voltage powers up our camshaft position sensor. It also powers up the other camshaft position sensor. It also powers up our wastegate vacuum sensor, and it also powers up the manifold absolute pressure sensor. Now, moving down to pin number 18, you can see that this is also labeled as VREF. And if we follow it out, you can see that this reference voltage feeds the crankshaft position sensor and our fuel rail pressure sensor. Now, a couple of other reference voltages that I found. Pin number 7, you can see it's labeled VREF. And if you follow it out, you can see it feeds the fuel low pressure sensor. And then down here, pin number 31, this reference voltage feeds the AC pressure transducer, the generator current sensor, and the turbocharger boost pressure sensor. Okay, so I found 3 more reference voltages here on this page, starting at the top. If you look at pin number 19, you can see it's labeled ETC ref. That's going to be the reference voltage for the electronic throttle control or the electronic throttle body. Then if you look down here on pin number 53, you can see it's labeled APP VREF number 1. This is going to be the reference voltage for the accelerator pedal position sensor. Now, of course, because the accelerator pedal position sensor is made up of 2 separate sensors, we also have another reference voltage here on pin number 46. You can see it's labeled APP VREF number 2. That's going to be the second reference voltage that goes to the accelerator pedal position sensor. So there we have all of our 5-volt reference signals. Now, as far as whether or not these signals are all separate from each other, I'm not really sure. The diagram does not give us that information. A lot of times these 5-volt reference signals actually come from the same source inside of the computer, but without the information on the diagram, there's really no way for us to know. I think that when it comes to checking the 5-volt reference signal, we'll probably just pick a few of them as a sample to see whether or not we're missing our 5-volt reference. So here we have page number 4 of 8 pages of the CAN bus communication system. Now, the reason I don't want to show you the rest of the diagram is because it really doesn't matter. We're mainly focused on the PCM. So if we look right up here, you can see this little box is going to be our powertrain control module. And if you look over here at pin number 54 and pin number 41, these are going to be our CAN high and CAN low lines. Now, if you guys aren't familiar with the CAN bus communication system, it's basically made up of 2 wires, the CAN high and the CAN low, and these 2 wires basically connect all of the modules on the vehicle together. Now, the reason this is important for us when we're doing testing is because we know that no matter where we check the signal in the CAN bus communication system, whether we check it at the transmission control module or at a connector or at the PCM, the signal should be all the same. So as long as we go to pin 54 and 41 here at the PCM and we find that we have a good signal and that signal matches the signal that we have at the data link connector, then we know we have good continuity between the PCM and the rest of the CAN bus communication system. All right, guys, so now that we've gone over the wiring diagram and we know what we need to look for, let's go ahead and move back over to the vehicle and start doing some checks. Now, as far as where to start, there really is no wrong way to do this. If you guys want to go directly to the PCM and start back probing there, I see nothing wrong with that. The PCM in our case is actually really easy to get to, so that wouldn't be a bad place to start. But I think what I'm going to do is I'm going to go ahead and start by checking the fuses. In particular, I want to check fuse number 69, this 20 amp fuse, because if we find that we have power here at this fuse, then that does tell us that this PCM power relay is powering up, which means that this PCM is grounding pin number 27. I think I'm going to start by checking some fuses in the fuse box. Then, like I said, if it's easy enough to get to, we'll start back probing the PCM. All right, guys, moving back over to the truck, let me take you over to the fuse box and show you where our fuse number 69 is located. Now, if we look at the lid over here, you can see that they actually gave us some numbers. And if you look, number 69 is going to be this fuse right here. So if we count from this relay, this is going to be the third one over, 1, 2, 3. And so this 20 amp fuse here is our 69. I've already got my power probe connected to the battery. You can see it over here. Let me go ahead and flick on my jump pack over here, and then we'll turn the ignition on. Our instrument panel is powered up. Now, just to test the power probe, I'm gonna go ahead and touch this battery terminal here and see that we have power. You guys can see it lights up red. So we'll touch this side. We have power here. Now I'm gonna touch the other side. You guys can see we have power there. So what does that tell us? That tells us that our PCM power relay is being turned on and our power should be getting sent over to the PCM. All right, guys, so because the PCM is so easy to get to on this vehicle, naturally this is going to be our next step. You guys can see I have our connector disconnected here, and if we take a look inside of the connector and the PCM, you can see that all of our pins look pretty good. None of them look bent or damaged, so that's a good sign. Now, what we could do while we have this connector disconnected is go ahead and check our grounds, because the grounds here are grounds at all times, so it doesn't matter whether we have this connected or not. And so if you look, you can see that we have pins number 1, 2, and pin number 4. Those are going to be our 3 main grounds. So I'm just going to take the power probe and we're going to touch those 3 pins, starting with pin number 1. You guys can see that we are showing a good ground. Now pin number 2, again, you guys can see we have a good ground there. And then finally pin number 4, you can see that we have a ground there as well. Now, of course, because our power probe is very sensitive to finding a ground, the next thing we're going to want to do is load test these grounds using a test light. In this case, I'm using an incandescent test light. You don't want to use an LED style because it doesn't take a whole lot of current flow to light up an LED light, and so that can be a little bit misleading. If you guys use an LED test light, the light lights and you think you have a good ground, even though you have high resistance in the ground. It's better to just use something like this. Again, an incandescent test light bulb is going to draw a lot more current than an LED test light bulb. And in this case, because we're working with the computer circuit, it's not really necessary to use something like a headlight bulb to test our grounds. Headlight bulbs can generally carry anywhere between 10, 15 amps of current. And generally speaking, computers do not carry that kind of current. So it's not necessary to use a headlight bulb. An incandescent test light will do just fine. So I'm gonna go ahead and start by touching pin number 1. You guys can see our test light is lit. Now, one thing I forgot to mention is that the other end of our test light is connected to the battery positive. Then the other thing that you'll notice here is that it's not only lighting up, but it's actually lighting up nice and brightly. So let's go ahead and move on to the next one. Pin number 2. Again, you can see that our test light lights up nice and bright. Then finally, we'll move over to pin number 4. And once again, you guys can see this test light lights up nice and bright. So we know that our problem is not with the ground. The next thing we need to do is check our powers. And we're gonna start by checking the powers coming in from the PCM power relay over here at our fuse box. Again, we checked fuse number 69 and we did have power there. Now we need to make sure that that power is actually reaching our computer. Now, in order to check our powers coming in from the PCM power relay, we're going to have this thing connected. Again, the PCM power relay is grounded by the PCM itself, and so having it disconnected like this, it's not going to work. So what we need to do is we need to remove the backing off of this connector so that we can have access to the wires while this thing is plugged in. On second thought, it's actually pretty easy to get to pins 5 and 6 from the back side of the connector. You can see that there's this big opening here. And if you look up here at the front, you can see that pins number 5 and 6 are these 2 down here at the corner. And if we look at the back side of the connector, they're going to be these 2 white wires up at the top. So we have really easy access to back probe these 2 wires without having to disassemble this connector. So I'm gonna go ahead and slide my back probe into one of these wires. Okay, so as you can see, I've got my back probe in on one of those wires. I'm gonna go ahead and reconnect this. There we go. I'm gonna power up the ignition again. Everything's powered up. Then we'll just go ahead and take this lead that I have connected to my back probe and I'm gonna clip it to the end of my power probe. And check it out. You can see that we have full battery voltage, 11.5 volts here. I'm gonna switch my back probe over to the other wire right there. And as you guys can see, we have full battery voltage there as well, 11.5 volts. Now what we can also do is load test the power using the test light. And so I'm gonna switch my clamp here from the positive terminal over to the negative terminal. And now when we touch a power, our test light should light. So I'm just gonna touch the tip of the power probe. As you guys can see, our test light lights up nice and brightly. Let me switch back over to the other wire, pin number 6. Slide this in, there we go. Then we'll check it with the test light once again. And as you guys can see, our test light lights up nice and bright. So that means that we do have good power coming in on pins number 5 and 6. Those are the powers coming in from our PCM power relay that's located in the fuse box over there. And we also verified that we have good grounds at the PCM. All right guys, so I'm back probed on pin number 14, which is our violet and orange wire. You guys can see I've got the back probe right there, and I've got the connector connected, and we're also attached to the power probe over here. So I'm gonna move inside the truck and I'm going to power up the ignition, and we'll power this thing up. Now let's take a look under the hood. Check it out. We have 11.3 volts. So we have system voltage on pin number 14, which is our wake signal coming from the BCM. All right guys, so over here on the PCM, I'm on pin number 15. You guys can see I have the back probe right there, and I'm on that yellow and orange wire, and I've got my back probe connected. And also I can take you guys over here to the fuse box where you can see our fuse number 90 right there, which is a 10 amp fuse. And it actually looks like somebody did replace this fuse before, but I can show you right now that if I test this fuse here, the test light does light on both sides. So that is a good fuse. We have power coming in and coming out. Now let's check it directly at the PCM. I'm gonna go ahead and stick this into the back probe and take a look at that. We have full battery voltage, 11.7 volts. All right guys, I am back probed on the can high and can low lines. And so if you take a look at my lab scope here, you can see I've got 2 channels up. We have channel 1 and channel 2. So if you take a look here at the yellow line, that's going to be our channel 1, and the green line is going to be our channel 2. Now the first thing that you'll notice about this signal is that it looks pretty good. I mean, we have our signal mirroring each other. So if you guys look, our channel 1, whenever the voltage goes low, our voltage goes high on our channel 2, vice versa. The second thing that you'll notice is that the signal itself looks pretty clean. We don't have any glitches or any dropouts. The signal is staying pretty steady. The only thing you guys might notice is this little intermittent spike that pops up every now and then. Basically what that is the end of an information packet, and so that is normal to see that. We can actually probably set our trigger on that so that we can catch it and you guys can see. Okay, so I've got that trigger set on this voltage spike. Again, this here is normal. This is indicating the end of an information package, and so there is nothing wrong with seeing this in the signal. And like I said, our waveform here looks pretty normal. And if you take a look at our voltages, you can see that we're hanging somewhere around 2.2 volts. So if you ask me, this proves that we have good continuity on the communication lines reaching the PCM. At this point, I don't believe there's any reason that the PCM shouldn't be communicating. All right guys, so I'm about to check the 5-volt reference circuit. Now let me show you my setup here. So if you can see, I got the connector out, and what I went ahead and did was I back probed pins number 15, 18 and 19. And so you can see I have 3 leads coming off right here, and so I'm going to be checking all of them at the same time. So I'm going to go ahead and reconnect this PCM. Okay, so I've got the PCM reconnected and I've got the ignition on. You can see I've got the power probe over here, and again I've got my 3 leads. So I'm going to start by using the red lead here, and I'm going to attach it to the end of the power probe. Now this lead is attached to our pin number 15, and so let's take a look at the power probe here. You can see that we are not showing any voltage here. So let's go ahead and switch over to the next one, which is going to be our green lead, and that green lead is going to be pin number 18. So I'm just going to grab our green lead for pin number 18, and I'm going to touch it to the end of the power probe here. And as you guys can see, we do not have a 5-volt reference there. So let's go ahead and switch over to the last one, which is going to be our yellow lead, and that's going to be pin number 19. So I'm going to go ahead and clamp it to the end of the power probe here. And once again, you guys can see that we do not have a 5-volt reference. All right guys, so now that we verified that we don't have a reference voltage here at our engine computer, the next thing that we need to do is verify whether or not we have maybe a shorted sensor that is bringing down our reference voltage to ground. Now, I will say this is highly unlikely because It seems that we have 3 different reference voltages, and for each of them to be taken down to ground is highly unlikely unless somehow internal to the computer all 3 of those reference voltages are shared. And so I really don't think that we have an issue with the shorted sensor. However, there is a quick way that we can test to see if we have a sensor that may be shorted to ground. And so what I'm going to do is, over here on my power probe, you can see that I'm still attached to the red lead, which is on pin number 15. And once again, you can see we don't have any voltage. Now, the thing about the power probe is that it is very sensitive to finding a ground. So right now you'll see this green light light up. It looks like it's got a short to ground. However, seeing this is actually probably normal, because more than likely what's happening is that this power probe is just finding some type of path to ground through the engine computer. Or it could be finding a path to ground through any of the sensors that are connected in that circuit. So in order for us to verify whether or not we actually have a short to ground, what I'm going to do is I'm going to use a test light. And again, just using an incandescent test light. Right now I have the lead for the test light connected to the battery positive, so that when I touch a ground, you guys can see that the test light will light. And so what's going to happen here is, if I touch the tip of this power probe and this test light lights, that's going to tell us that we actually have a short to ground. Now, if the test light does not light and we read voltage on the power probe, that's going to tell us that the PCM simply just is not outputting a 5-volt reference. So I'm going to go ahead and touch the tip with the test light. And as you guys can see, our test light does not light and our power probe is showing battery voltage. So that's proof that we do not have a short to ground on that particular circuit. Now, again, we have 3 different reference voltages, so we need to check our other ones. Okay, so now I'm connected on the green lead, which is back probed into our pin number 18. And again, I'm going to touch the test light here to the tip of the power probe, and whoop. And as you guys can see, our test light does not light and we show battery voltage. So we don't have a short to ground here. Now finally, we are attached to our yellow lead, which is connected to our pin number 19. And so I'm going to go ahead and touch the tip of the power probe. And again, as you guys can see, our test light does not light and we show battery voltage on the power probe. So that is 100% proof that we do not have a short to ground in our reference voltage circuit. Our computer simply just is not putting out a reference voltage at all. One of the things that you want to do before condemning a bad PCM, or any module for that matter, is a pin fitment test. And so what I'm doing here is I've got my back probe. This one here feels like it's actually the perfect size. And what you want to do is you kind of want to just check the terminals for drag. And so what I do is I basically just stick the back probe into the terminal very gently, careful not to spread the terminal open, and just feel for how much drag you have, and then move over to the one next to it and compare it. And so I can tell you right now, these feel pretty tight. If I check the next one, it also feels pretty tight. The next one, it feels pretty good, and so on and so forth. Now, I've already gone ahead and checked all of the terminals on this connector, and they all feel good. So at this point, I'm pretty convinced that we need a new PCM. All right, guys, so there you have it. I'm pretty much as close to 100% as possible that this thing is gonna need a new PCM. Now, can I be 100% sure? I mean, I can't say that I can be 100% sure. Is anyone ever 100% sure when it comes to these things? No. However, we did all of the testing necessary in order for us to be as confident as we can possibly be when it comes to calling a bad engine computer. So I'm gonna let the shop know. Hopefully they can order a computer today. Maybe we can get this thing programmed, and hopefully I can show you guys this thing running.
One eternity later.
All right, guys, so fast forward. It's now been over a month since I shot that video. Like I mentioned before, I am behind schedule as far as posting my videos. I do apologize. I have quite the backlog of videos that I'm working on editing. During the summertime, I get really busy with my everyday work. So again, I apologize if I'm not posting as consistently as I usually do. Just know that I am making it a priority to get these videos out, and that I really appreciate you guys' patience. Anyway, as far as the update with this vehicle, like you saw in the video, we did all of our checks. We checked our powers, our grounds, our communication lines, our 5-volt reference, and what we found was that the computer had everything it needed in order to operate. So condemning the PCM in this case was pretty straightforward. Now, unfortunately, I didn't make it back in time to the shop to show you guys the final product after they replaced the PCM. I was really hoping to show it to you guys, and I was also hoping to show you guys the procedure for programming the PCM on a Ford. However, the shop decided to purchase a remanufactured PCM that came pre-programmed, and so they really didn't need me to come out and program the PCM. It was pretty much plug and play on their end. Once they installed the remanufactured PCM, they were able to start the vehicle right up. So anyways, guys, at this point, I'm gonna end out the video. Like I always say, thank you guys for watching. I hope you found it useful, informational, educational, entertaining. If you did, make sure to give it a thumbs up. If you haven't done so already, make sure you subscribe to the channel, hit that notification bell, I'll see you guys in the next one. Thanks.